Hello there and welcome to the GCSE revision video. Here we're looking at functions, so let's just jump right straight into it. So there are 5 skills that we want to develop here. We want to be able to put a value into a function. We want to put a value into a composite function, so composite inputs. The third thing is creating composite functions, so that's one function combined with another function. 4, finding inverse functions, so that's a function that will do the opposite function of the current function, and then using all of these above to solve equations with. So that's what we're going to look at. Let's start with the first one. So pause the video and have a go at these input functions questions. Okay, so let's get started. So f of 5. Now what f of 5 means is it means replace x in the f function with the number 5. So it's going to need to go 2 times 5 minus 7. So that would be 10. Take away 7. That's 3. G of 12. So that means replace x with the number 12 in the g function. So that's going to be the square root of 12 minus 3. 12 minus 3 is 9, and then the square root of 9 is 3. F of minus 4, that means replace the x value with the number minus 4, so 2 times minus 4, take away 7, that's minus 15. G of 52, that means replace x with the number 52 in the g function. So 52 minus 3 is 49, and the square root of 49 is 7. And f of 0.5, that means replace x with the value 0.5, so 2 times 1.5, so times 0.5 minus 7. 2 times a half is 1, so it's 1 minus 7, which is minus 6. Okay, let's have a go at these 5 questions here now. The functions are a little bit more challenging than before, but I just want you to put these values into the corresponding functions. Okay, let's get started then. So putting 4 into the f function, so that would be 4 plus 2 is 6 over x, which is again 4. So this function here had 2 places I had to put the 4 in. 1 4 on the top and 1 4 on the bottom. 6 over 4 is equivalent to 1.5. G of 5, that means replace x with the value 5 in the g function, so 5 minus 2 squared, that's 3 squared, which is 9. Minus 1 into the f function, so minus 1 plus 2 over minus 1. So that's going to be 1 on the top, minus 1 on the bottom. 1 divided by minus 1 is minus 1. G of minus 7, so that's going to be minus 7, take away 2 squared. So that's going to be minus 9 squared, which is 81. And f of 0.5, so that's going to be 2.5. divided by 0.5, and when you divide by 0.5 you're actually doubling it, so that would be 5. Okay, so there we are. Those are the questions on simple input values. Let's now have a look at some composite input values. Now just a reminder, with these composite inputs you actually do the function that's closest to the number first, so you don't go from left to right, you actually go from the letter that's closest to the number first. So for this question here, 6 is going to go into the g function first. You'll work out what that answer is, and then you'll put that answer into the f function. So it goes through 2 machines. It goes through the machine for the g function, and then it goes through the machine for the f function. I'll let you pause the video and have a go at these questions here. Okay, so let's get started then. So what I need to do first is I'll leave the f alone at the front, and then I'll put 6 into the g function. When I put 6 into the g function, I'm going to get 30 out of it. And now with that answer of 30, I'm now going to put 30 into the f function. So I'm going to replace x with 30 in the f function, so that'd be 37. Moving on to the next one. In this question I need to do the 3 into the f function first. So I'm going to leave the g alone at the front, and I'll put 3 in as x into the f function. That'll make it 10. And then 10 going into the g function, that'll make it 50. For the next question, we need to put minus 5 into the g function. So minus 5 times 5, that's minus 25, and I'll leave the f alone at the front. And now I do the f function, so minus 25 add 7 is minus 18. With this function here, it's 3 functions, so I'll do the one closest to the number first, and then I'll work my way outwards. So gf can be the letters that stay at the front on the left two hand sides, and then I'm going to put 4 into the g function. That'll make it 20. Then I'll put 20 into the f function, so working my way backwards, 27. And then 27 into the g function. I think I'll need to grab my calculator for this one. 5 times 27 is 135. And there we are, that's the answer to that one. And moving on to the final one, we've got lots of f functions here, so we'll perform it once to leave ourselves with 3 f's left. 6, put it into the f function, you get 13. Do another f. So I'll have 2 f's left at the front now. 13 plus 7 is 20. And do another f, 20, put that into the f function, I get 27. And then put the 27 into the f function again, and I get 34. So it's just continually putting the output into the f function in that question. Okay, we're now going to move on to composite functions, and I'll show you how to do the first one. So what we need to do is we need to make a combined function that does both of the functions in the order f first, because that's nearest to x, then g afterwards. So here's how I like to think of it. I like to think of gf of x as g of f of x, but now it's got the pair of brackets around the f of x. The next thing I'll do is I'll do the inside of the brackets first, and I'll replace f of x with the function x plus 7. So I'll replace f of x with the function x plus 7. Now once I've got x plus 7, I now need to take x plus 7 and put it into the g function. So the g function does 5 times the bracket value, x in this case, but in this case it's going to be 5 times x plus 7. I've effectively taken the g function and replaced the x with x plus 7 this time. So this is the combined function for gf of x. So the answer, gf of x equals 5 bracket x plus 7. Let's just do one more before I give you a chance to have a go at this question. So what we do again is we take the f of x function, because that's the one nearest to x, and we write it in a different pair of brackets. The next thing we do is we rewrite out the function for f, and that in this case is x minus 3. So I'll put x minus 3 in the bracket there. Then I'll take x minus 3 and put it into the g function where x is, so it's going to turn into x minus 3 squared. So I've taken the x minus 3, replaced it with x here and x here, so it's x minus 3 squared. Alright then, so your turn to have a go at a couple of questions here then, so pause the video and have a go at creating the composite functions gf of x and fg of x. Okay, so in this question here, what we need to do is we need to replace the f function first. The f function is x divided by 3. Now what I'm going to do is I'm going to take x divided by 3 and put it into the x positions in the g function. So that would be gx over 3 equals x over 3 plus 4 being on the side. Okay. Moving on to the next one, let's do the g function first in this case. So it's going to be f, we'll leave f alone at the front. G function first, this time x plus 4. And now I'm going to take x plus 4 and I'm going to put it into the f function where x is. So it's going to be x plus 4 all over 3. And there we are, that's the answer to these two questions. And you can see that they're different. Gf of x does not always equal fg of x. This is the answer to these two questions. Let's do a bit more practice. Let's pause the video and have a go at these questions here. Okay, so in this first question we do the f function first, so that in this case is the square root of x. And then we take the square root of x and we put it into the g function. So it's going to replace x in the g function. So it's 4 times the square root of x plus 3. So there we are, that's the answer to that question. Let's move on to the next one. So this time we do the g function first, and the g function here is 4x plus 3. Then we're going to take all of this value here and substitute it into the x value in the f function. So it's going to be square root 4x plus 3, where the whole thing now is inside the square root. Okay, so hopefully that made sense. Let's have a go at a couple more. Pause the video and have a go at this question here. Okay, so let's get started then. So in this first question here, we do the f function first because that's closest to x. It's going to be x plus 3 over x. The next thing we're going to do is we're going to take all of this big fraction here and substitute it into the x value in the g function. So it's going to be 5 times by all of this thing in the bracket that's replacing the x. X plus 3 over x. In the second function, it's going to be f of g. So let's rub that little line out, otherwise it will get confusing. So it's going to be the g function first, that's 5x. And then what I'm going to do with 5x in this question is I'm going to have to substitute it into every position where there is an x in the f function. So it's going to get replaced into 2 different positions. 5x plus 3 and then over 5x again. So there we are, that's the answer to these 2 questions here. So a little bit more difficult this one because the g function had to be substituted into 2 positions in the x function. Wherever there's an x, 5x needs to be substituted in. Okay, and now we're going to move on to the topic of inverse functions. So I'll show you how to do the first one. What we're effectively going to do in the first one is we're going to set x minus 3 over 2 equal to some output value, and we'll call that output value y. So we're going to use x as the value for the inputs. We've just currently been doing inputs into functions, but y is going to be the letter to represent the outputs. Now what an inverse function is it takes outputs back to inputs. It does the opposite of the function. A function would take an input to an output, but an inverse function does the opposite. It takes an output back to an input. So what we need to do here in this question here is to rearrange this equation to make x the subject so that I've got then a function to do to y to get it back to x. So this is a rearranging formula question. In this case I'm going to times by 2 first to move the divide by 2 onto the other side. And then I'm going to add 3 to both sides. So I'm doing this to both sides here. I'm going to add 3 to both sides to cancel out this taking away 3. So it's going to be x equals 2y plus 3. And now I have a function to apply my output to get myself back to the input value. The way I write my final answer is going to be f to the power of minus 1x, that's the standard notation for inverse function, equals 2x plus 3. So you can see the difference from this line to this line. All that's different is that the y letter is replaced with the x letter, just because functions are generally written with the letters x rather than any other letter. It's just standard notation. So to go through this question again, you take your function and set it equal to the output value, y. You then rearrange the equation to make x equals. Then your final answer will be 2x plus 3, where it's the function of the output to get back to the input. Okay, I'll be quiet now, pause the video and have a go at this g function over here. Okay, so let's have a go at this question here then. So we take our function and we set it equal to the output value, y. And now we've got to rearrange to make y the subject. So to make x the subject. I think I'll expand the brackets first, although you could have divided by 7 first. Now in a rearranging equation question, it's always best if you can move the negative x onto the other side. So whenever it's minus x, it's always better to make it a positive by moving it onto the other side. So add 7x. If I'm making x a subject, I would ideally like it to be positive. So it's going to be 7x plus y. I'm making x equals here, so I'm going to now take away y from both sides. 35 take away y equals 7x. And the last thing I need to do is get rid of this multiply by 7, and I will do that by dividing both sides by 7. So 35 minus y over 7 is equal to x. So therefore the final answer here would be g to the power of minus 1, because it's a g function, equals 35 minus, we don't write the letter y, we write the letter x, over 7. So there we are, that's the answer to that question there. So these inverse functions questions are basically rearranging formula questions. Take your function, set it equal to y, rearrange the formula, and then write your final answer. Let's have a go at these two more tricky questions here. Pause the video and give these two a go. Okay, so let's get started on the first one then. So we set y equal to our function, 3 minus 4x. Then we start rearranging, so we'll square both sides. It's minus 4x, so what I'll prefer to do with that, I think, is make it positive by moving it onto the left-hand side. Then I'll take away the y squared. And then I'll divide by 4. And there we are, that's the answer, but I'm going to write my final answer as f inverse x equals 3 minus x squared over 4. Remember, I replaced the y letter for the x letter. So there we are. Let's move on to the next one. So we set y equal to a squared minus x squared. The x squared is negative here, so I'll prefer to add it onto the other side if I can help it. Then I will take away the y squared take away the y onto the other side. And then I'll square root, so it's going to be x equals the square root of a squared minus y. So therefore, g inverse, g to the power of minus 1x, equals the square root of a squared minus x. Remember, you replace the y letter for the x letter there. Okay, so there we are, that's the answer to these two questions. Let's move on to the next couple. Pause the video and give these two a go. Okay, so in the first one then, it's y equals 9 over x. We want to move everything onto one row. We don't want any fractions if possible. So we'll multiply both sides by x. That will undo the divide by x. So it's xy equals 9. Okay, we want to make x a subject, so we need to get rid of this y. It's being multiplied to the x. We need to undo that multiply, divide by y in the next step. So it's going to be x equals 9 over y. So therefore, the final answer to this question is f inverse x equals 9 over x. And there we are, that's the answer to that question. And notice how it's a self-inverting function. You can see 9 over x here, 9 over x here. It's just a pattern of these types of functions. Won't necessarily be true for this one. Let's try it out. Y equals 5 over 2 minus x. So what we're going to do here is we're going to group together this 2 minus x and then multiply it onto the other side. So multiply by 2 minus x, so it's going to be y multiplied by 2 minus x in a pair of brackets. The next thing we'll do is we'll expand those brackets. The next thing I'll do is I'll spot I've got a negative x here, and I always prefer to have positive x's if possible, so I'll add it onto the other side. Then I'll take away the 5, and then I'll divide by the y as my final step. I think I'll recharge up here. So divide by y, 2y minus 5 over y equals x. So therefore, the inverse function here, g inverse of x, is going to equal 2x minus 5 over x. And there we are, that's the answer to that question. And let's move on to the very final one for the inverse functions, a real tough one this one. It's got x's in 2 places, which makes it even harder for you. Pause the video and see if you can do it. Okay, so let's get started. I'll give myself some long columns to do this in. So y equals 2x minus 5 over 3x. Well, same as last time, I want to get rid of the fraction element for this question, so I'll multiply both sides by 3x to undo the divide by 3x that's happening here. So 3x times y equals 2x minus 5. Okay, I need to get all of my x's on the same side and reduce the amount of negatives that I have. I think what I'll do is I'll add the 5 onto the other side. And then I'll take away the 3xy onto the right hand side, so 2x minus 3xy. Okay, so now that I've got all of my x's on the same side and I've reduced the amount of negatives that I've got in this question, I now need to factorise. So I'm going to factorise out x from the right hand side. So it's going to be 2 inside the brackets and then minus 3y also inside the brackets. What I've done here is I've converted a question that has 2 x's in it into a question that just has 1 x in it, because ideally I'm looking to write x equals and there's something to do with y on the other side. The next thing I'll do is I'll then divide by what's inside this bracket, 2 minus 3y. It's all going to be divided, so it all therefore ends up on the bottom of a fraction. So therefore, the answer to this question, f inverse x equals 5 over 2 minus 3x, replacing the y letter for the x letter. So it's a case of multiplying first to move everything onto one straight line. We don't want any fractions if we can help it. Move all your x's onto one side, doesn't matter if it's on the left or the right. You want to reduce the amount of negatives you have as well if possible. Factorise out the x, that's the really important step from this bit to this bit. Factorise. And then divide by the bracket and you get your final answer. Okay, let's move on to the fifth skill that you have to be able to do with functions now, and it's solving functions. So I'll go through this one with you. We want to, for the function f of x equals 5x minus 7, solve f of x equals 33. That's effectively find out what x value will give you 33 as your output value. So what we can do here is we can set up 5x minus 7 equals 33. And if I now solve this equation, title of this is solving equations, I can work out what the x value is to get 33 as the answer. So I'll add 7 onto the other side first, and then I'll divide by 5, so I get x equals 8. So 8 would be the input number for an output number of 33. Try it yourself. If you put 8 in here, you get 40, take away 7 is 33. So therefore x is the input value for the corresponding output value of 33. So it's a case of solving a little simple equation. Take your function and set it equal to what your function equals. Alright, your turn to have a go at this slightly trickier one here, then pause the video and give this one a go. Okay, so we want to find the input value that will give us an output value of 7. So what we need to do there is set up a little equation. 5x plus 4 square rooted equals 7. So I need to undo this square root first, and the way you undo a square root is by squaring. So it will get rid of the square root on the left, but now I need to square the right. That will give me 49. I'll then take away 4 from both sides, so 5x equals 45, and then divide by 5 so I get x equals 9. So 9 is the output value, if my 9 is the input value that will give me an output of 7. Okay, let's have a go at this more tricky one then. It's one that involves a composite function and then equals 77. Pause the video and give this one a go. Okay, so first thing we need to do is make the composite function. So it's going to be f g of x. So f g of x, so I do the g function first, remember, that's going to be x squared, and then I put that x squared into the g function, so into the f function, so I imagine it going in as x into the f of x function, so it's going to be 3x squared plus 2. So now that I've got my f of g function, I can now start solving this equation. 3x squared plus 2 equals 77. first thing I'll do is I'll take away 2 from both sides, so that'll be 75. Then I will divide through by 3, so that'll be 25 now. So x equals either plus or minus 5. Remember, 5 squared gives you 25, but so does minus 5. Minus 5 squared gives you 25 as well. Okay, so it could involve composite functions here. And this one is a very tricky one here. Fg of x equals gf of x. So make the two composite functions, set them equal to each other, solve your little equation. Alright then, let's give this one a go then. So the left hand side, fg of x, is going to equal, we had it before, didn't we? It was 3x squared plus 2. Now gf of x is slightly different. We do the f function first here, so that's going to be 3x plus 2. And then we put that inside the g function, so 3x plus 2 goes in as x into the g of x function, so it's going to be 3x plus 2, all being squared. So these are our two functions, and now we just need to solve the equation for when they're equal to each other. So what we're going to be doing then is solving 3x squared plus 2 equals brackets 3x plus 2 all squared. Now let's just remind ourselves what we do when we square a bracket. We effectively times that bracket by another version of that bracket, timesing it by itself. So expanding the brackets, 9x squared plus 6x plus another 6x plus 4. So it's going to be 3x squared plus 2 equals 9x squared plus 12x plus 4. Okay, and now it looks like a quadratic equation. We now need to move everything onto the same side, so I'm going to move both of these two left-hand parts onto the right. So I take away 3x squared, so I've got 6x squared left. And I'm also going to take away 2. So I've still got my plus 12x, but now I take away 2, so I've got 2 left. 2 taken away from 4 is 2. What I could then possibly do is divide everything by 2, because they're all even numbers. That will make the question a little bit easier. And now I'm going to need that quadratic formula. So it's going to be x equals minus b, that would be minus 6, plus or minus the square root of b squared, that would be 36, minus 4 times 3 times 1, over 2a, so that's going to be over 6. So I'll just reach for my calculator and type them all in now. So fraction button, minus 6 plus root 36 minus 12 over 6, and I get an answer of minus 0.18, and then there's plus or minus, so I need the minus solution now. I'll go back and use the arrow keys to change the plus to a minus, minus 1.8, minus 1.82. Lovely, there we are. That's the answer to that question there. Pretty tricky question that, but they do come up, so please be aware of them. You could involve a quadratic formula in these types of questions. Alright then, so let's move on to the practice questions then. We're now on to the questions that have appeared from past papers in the past. Pause the video and have a go at this one. Okay, so let's get started then. So find f of 3. So this is a nice easy question to get the ball rolling. You just put 3 in as x into the f function. So it's 6 plus 5, that's 11. Find inverse of f. Okay, so the way we do that is we do y equals 2x plus 5. We rearrange it, so it's y minus 5 equals 2x. And then we divide through by 2. So it's y minus 5 over 2 equals x. So therefore the inverse function is x minus 5 over 2. Remember, you change the y letter for the x letter just in your final answer. Moving on to the next one, the g function is x squared minus 25. Find g of minus 3. So minus 3 squared we know is 9. 9 take away 25 is minus 16. Find gf of x, give your answer as simple as possible. So gf of x, so I'm going to do the f function first. So that's going to be g of 2x plus 5, the f function first. Then the 2x plus 5 goes in as x into the g function, so it's going to appear where x is, so it's 2x plus 5 all squared minus 25. Okay, and I could probably expand the brackets on this a little bit, so remember when I expand double brackets, it's that bracket times another version of that bracket. So it's going to be 4x squared plus 10x plus another 10x from the other bit, 5 times 2x, and then plus 25. So it's going to be 4x squared plus 20x plus 25, but minus 25, so that's my final answer here. So that was the answer to part D. Let's now move on to answer part E. Solve gf of x equals 0. Well, I've already done the legwork for gf of x, really, so it's 4x squared plus 20x, and then I need to solve it equal to 0, so I'll write equals 0 afterwards. So now I need to solve this. The first thing I'll probably do is I'll probably divide by 4, just to make things easier. 0 divided by 4 is still 0. And then I'll factorise the brackets. So it's going to be x bracket x plus 5. And now, if you remember from quadratics, I've got two expressions that are multiplying together to make 0. So that must mean that one of these things equals 0. So either x is 0 or x plus 5 is 0, in which case x needs to be the number minus 5. So there we are, those are the two solutions for this question, either 0 or minus 5. Okay, so that's that question. Let's move on to the next one. Pause the video and give this one a go. Okay, so in this question I'm putting minus 5 into the f function to get the ball rolling. So f minus 5 equals 2 over minus 5 all squared. Remember, minus 5 is 25, so it's 2 over 25. And I'd leave my answer there, I think. Moving on to part B, it's fg of 1. So I put 1 into the g function first, because it's closest to the 1. So 1 substituted in here would be 1 times 4 is 4. And then 4 into the f function next, so it's going to be 2 over 16, or 1 over 8 as a simplified fraction. That question wasn't too bad. Let's move on to the next one. Pause the video and give this one a go. Okay, so let's have a go at part A then. So find f of 1. That means just substitute 1 into the f function. So it's going to be 3 over 5. 4 plus 1 is 5. I'll just leave my answer as 3 over 5. Moving on to part B, state which value of x must be excluded as a possible input value for f. Well, very good question here. Now remember, whenever you're doing a fraction, you can never divide by 0. So when would the denominator equal 0? The answer is when x is equal to minus 4. When x is the number minus 4, you'll have 4 take away 4, which will give you 0 on the bottom as a total. So the answer to this question here, part B, is minus 4. The function g is defined by 5 plus x. Given that g of a equals 7, find the value for a. Well, this question isn't too hard. I don't really need to do any complicated maths for this one. It's think of a number that when you add 5 to it, you get 7. That answers 2. When you put 2 in as the function, as the x value here, you get 5 plus 2, which will give you an output of 7. That wasn't too hard, that one. Moving on to the next one, fg of 1. So it's going to be f, and then we put 1 into the g function first, so that'll make it 6. And then 6 goes into the f function next, so that'll be 3 over 10. And I'll leave my answer as 3 over 10. Part E, find f g of x and simplify your final answer. So it's going to be f, and then the g function happens first, so it's x plus 5. And then what I do with that is I then put the 5 plus x into the f function. So it's going to go in where x is into the f function. So it's going to be 3 over 4 plus 5 plus x. And now I can tidy up the bottom a little bit, it'll just be 9 plus x. So there we are, that's the answer to f g of x. Okay, let's move on to the next one. Pause the video and give this one a go. Okay, so part A is a similar question to before. What value of x am I not allowed to put into the f function? So state which value of x is not valid for the value of f. Sorry, that's supposed to be f. It would be minus 5. Minus 5 is the x value that will make this denominator equal to 0. Find g of 10, so that just means put 10 into the g function, and that will give us 23. Calculate gf of minus 7, so that means I have to put minus 7 into the f function first. So that will give us 1 over minus 2, or minus a half. And then moving on to the next bit, I put minus a half into g, so that's going to give me minus 1 plus 3, and that gives me 2. D, express the inverse function g inverse in the form g inverse of x equals. Okay, well, this question is not too bad. It's just y equals 2x plus 3. Do a little bit of rearranging, so take away 3 first, and then divide by 2. And then it's just write your final answer as x minus 3 over 2. Alright, let's move on to the next one. Pause the video and give this one a go. Okay, so let's have a go at part A then. So part A is gf of x equals this thing here, or show that gf of x is this thing here. Okay, well, I'll ignore this for now, and then hopefully my answer will be this. So it's going to be g of f of x, and f of x is this expression here, x plus 1 all squared. And then I'm going to put x plus 1 all squared into the x position in the g function. So that's going to make it 2 bracket x plus 1 squared minus 1. Okay, well, this is a bit complicated algebra, so let's tidy up the inside of this bracket. Remember, when you do x plus 1 squared, it's actually, think of it as x plus 1 times itself, x plus 1. So that's going to give us x squared from x times x, plus another 1x, plus another 1x, so that's 2x, and then plus 1. So it's going to be x squared plus 2x plus 1, then minus the 1 afterwards because there's a minus 1 at the back here. Then it's going to be x squared plus 2x, and then we can cancel out the 1's. And then I'm going to factorise out an x, so pull a factor of x out. So it's going to be 2x bracket x plus 2, and there we are, that's our final answer, that's what we were hoping to get, so we showed it. Okay, so when you've got to show that question, you can't use that as you're working for your answer in any way. You have to start with one side and then go through all the maths and then show that it's equal to the other side, and that should be your final answer. Moving on to part B then, g inverse of 7. So first I need to work out what g inverse is, and I'm running out of space here a little bit, so I'll move over here. So y equals 2 bracket x minus 1. So I need to find g inverse first, so I'm going to divide by 2, and then add 1. So my g inverse function is equal to x over 2 plus 1. So now if I do g inverse of 7, I'm putting 7 into this function here, so that would be 3.5 plus 1, that would be 4.5. So g inverse of 7 equals 4.5. I should possibly write it under this, shouldn't I? g inverse of 7 equals 7 over 2 plus 1 equals 4.5. That'd probably be a better place to put it on the page. Alright, so there we are, that's the answer to that question there then. Let's move on to the next one, pause the video and give this one a go. Okay, so let's get stuck into this question here. So we've got f of 4 as the first question up, so all that means is plug the number 4 into the f function, so that's going to be 8 minus 5, that's 3. Find f g of minus 4, so that means take the number minus 4 and plug it into the g function first. G is the nearest letter to the number minus 4, so minus 4 gets put into g first. When you square minus 4, you get 16. 16 take away 10 is 6. Hopefully you didn't make a mistake on the double negative there. And then put 6 into the f function, that would be 12 minus 5, that's 7. So 7's the answer there. Express the inverse function f inverse in the form f inverse x equals. So what this means is we mean take your function and set it equal to y. And then we rearrange the function to make x the subject. So y plus 7 equals 2x. Divide through by 2. And we get that expression there. So the final answer here is going to be f inverse x equals, now remember in our final answer we don't use the letter y, we use the letter x, so it's x plus 5 over 2. And there we are. Moving on to part D, solve gf of x equals minus 1. So for this question we're going to need to make the function gf of x. This is the function that will do the f function first, then the g function second. So what's the f function? The f function is 2x minus 5. And then we need to do the g function to this thing here. Now what that means is take whatever's in the bracket and replace it for x in the g function. So it's going to be bracket 2x minus 5 all squared minus 10. And then we need to do the question, so this is now going to equal minus 1. This thing here is equivalent to the g of f function. This function here does the f function first and then it does the g function second. And we want to find out what x value will give us minus 1 as the output. So what we've got now is we've now got an equation that we can solve. So first thing I'll do is I'll add 10 onto the other side. So 2x minus 5 squared equals 9. Adding 10 to the other side. The next thing I'll do is I'll now square root. Now, when I square root this, I'm going to get 3, but I could also get minus 3, because remember, if I was to square the number minus 3, I'd get 9 as well, so this is actually plus minus 3. So what I'm now going to do over here is I'm now going to make two separate equations to work out what x needs to be. 2x minus 5 equals 3 will be the first one, so that means that 2x equals 8, so therefore x equals 4. And also 2x minus 5 could equal minus 3. So therefore I'll add 5 onto the other side, and I'll get 2, and then I'll divide by 2 and I'll get x equals 1. Another way of doing this question would have been to have expanded the brackets and solved it by a quadratic formula, in which case you would have got the same answers in both cases. So the answer here are 4 and 1. They are the x values that you can plug into the f function, then plug the answer into the g function. That should give you an output of minus 1. Okay, let's move on to the next question. Pause the video and give this one a go here. Okay, so let's have a go at part A then. Part A is express the inverse function for f. So that's going to be 3x minus 2 equals the output letter y. So now we're going to rearrange this to make the output letter in the formula, or the input letter the subject. Divide by 3. So therefore, the inverse function f minus 1x equals, remember we don't use y in the equation, we use the letter x. So this is the function that will undo the f function. Find g(f) of x, simplify your answer. So g(f) of x, remember the first function we do here is the f function. So it's going to be g of the f function first, that's 3x minus 2. And then we put this value into the x position in the g function. So it's going to be 10 over 3x minus 2 and then plus 2 afterwards. So in actual fact, this is going to simplify to 10 over 3x. And that's the equation, that's the function for g(f) of x. Okay, let's move on to the next one. Pause the video and give this one a go here. Okay, so in this question here, we first for part A need to find the inverse function for f. So remember what you do there is you use your function and set it equal to an output letter y, and then rearrange the formula to make x the subject. So therefore the final answer, we don't use the letter y in the final answer, we use the letter x in the final answer, x plus 1 over 3. Now moving on to the harder bit of this question here, part B, which is f g of x equals 2 lots of g(f) of x. Show that 15x squared minus 12x minus 1 equals 0. It seems like these two bits here are completely disconnected. Well, in actual fact, what they want you to do is they want you to create the functions f g of x and 2g(f) of x, and then set the two things equal to each other. This is the key to the question here. So, in this case here, we're going to have to create the f g of function first. So this means we do the g function first, that's x squared plus 4. And then once we've done that, we put x squared plus 4 into the f function. So it's going to be 3 brackets x squared plus 4 minus 1. So it's going to be 3x squared plus 12 minus 1. So it's going to be 3x squared plus 11. Okay, so that's the left-hand side of the equation. Now let's do the right-hand side of the equation. We need the f function first. That's going to be 3x minus 1. We'll leave the 2 alone at the front for now. But we need to now put 3x minus 1 into the g function. So it's going to appear where the x appears in the g function. So it's going to be 3x minus 1 squared plus 4. Let's leave the 2 alone at the front for now. And now we need to expand these brackets here. Remember that the way you expand a squared bracket is you multiply that bracket by itself. So it's going to be 9x squared plus, minus 3x, take away another 3x, and then minus 1 times minus 1 is plus 1. So the answer here is going to be 9x squared, and then it would be minus 6x, and then it would be add 1, but we've already got an add 4, so it will now be add 5 in total. So in this case, it's now going to become 18x squared. We're now bringing the 2 into the equation here, multiplying it out of the bracket, 18x squared minus 12x plus 5. Okay, so that's equal to the right-hand side of the equation. Now we just need to do the show that part. 3x squared plus 11 equals 18x squared minus 12x plus 5. So I need to make it 15x squared. So the first thing I'll do is I'll take away 3x squared. So that'll leave me 11 equals 15x squared minus 12x plus 5. I've got the 12 minus 12x already, and I now need to, so it's not coming out. This needs to be 10, doesn't it? Whoops. It needs to be 10 because 2 times 5 is 10, so that should be a 10 over here. We all make our silly mistakes, don't we? So add the 10 there, and then take away 11, so it's going to be perfect. It's going to be 15x squared minus 12x minus 1, because we take away 11. And there we are, that's our final answer. So it's a good job that that question was a show that question, otherwise I would have made that silly mistake there. When you've got to show that question, always check what you're doing, that it will line up with what you're supposed to show. And sometimes you'll make a silly mistake, and that's the benefit of show that questions. You know what the answer is going to be, you just have to show all the steps for getting there. Okay, let's move on to the next question then. Pause the video and give this one a go. Okay, so this question here starts with a bog standard find the inverse function, so it would be 4x minus 1 equals the output letter y. Let's now rearrange 4x equals y plus 1, and then it's going to be x equals y plus 1 over 4. So the inverse function is going to be this thing here, not with the y in it though, with the letter x in it, x plus 1 over 4. Okay, moving on to part B then, the function g is such that g of x equals kx squared, where k is a constant. Part B is given that fg of 2 equals 12, work out the value for k. So what we're going to do is we're going to leave k in the question, so create an equation that equals 12, and then find out what k needs to be after that. So fg of 2 is going to equal f, now we put 2 into the g function first, that's the closest letter, so that's going to make it k times 2 squared. We all know that 2 squared is 4, so it's going to make it 4k. And then we're going to put 4k into the f function where the x value is, so it's going to be 4 times 4k, that's 16k, and then minus 1. And then this thing here, 16k minus 1, is going to equal 12. I've created the function fg of 2, that's this thing here, and then I need to set it equal to 12. So the next thing I'm going to do is set 16k equal to, add 1 onto the other side, that makes it 13, and then divide by 16, 13 over 16 is the answer to that question. Okay, let's move on to the next question then. Sorry, it's a bit small here, pause the video and give this one a go. Okay, so for part A, work out f of 6. That just means put 6 in the f function. So it's half of 6, which is 3. 3 add 4, that makes it 7. The next part, work out fg of minus 3. So I'll put minus 3 into the g function first. So that's going to make it minus 6 over minus 3 plus 1, that makes it minus 2. Minus 6 divided by minus 2, negative divided by negative is a positive, 6 divided by 2 is 3. So it's positive 3. And then I'm going to put 3 into the f function, so half of 3 is 1.5, plus 4, that makes it 5.5. G of a equals minus 2. Work out the value of a. Okay, so in this question here I need to work out what the input letter is for the output value of minus 2. So let's start with writing out what g of a will equal. That means put a into the g function. So it's going to be 2a over a plus 1 equals minus 2. So what I've done here is I've put a into the g function in the positions where x is. And this needs to equal minus 2, and I need to now work out what a is. I need to do some rearranging algebra to work out what a needs to be. So I've got this as my little equation here. First thing I'll do is I'll multiply by the denominator of the left hand side, so times by a plus 1. That gives me 2a equals minus 2 times a plus 1. Let's expand the brackets. 2a equals minus 2a minus 2. And then I'll add the 2a onto the other side, so I've now got 4a on the left hand side, divide through by 4, and I've now got minus a half as my value for a. And you can always check that by putting a, so minus a half back into the g function, and we should get minus 2 out there. That was part C there. Moving on to part D now. Express the inverse function of f in the form f inverse x equals. So this means take the f function and set it equal to the output letter. We'll give it an output letter of y, and then we'll rearrange it to make x the subject. How do we get rid of a half? We double the other side, so it would be 2y minus 4. I could probably expand the brackets here, 2y minus 8. So therefore the final answer here is going to be f inverse of x. And remember, our final answer for inverse functions don't use the letter y, they use the letter x. So it's 2x minus 8. So there we are, that's the answer to that question there. Okay, let's move on to the next one. Pause the video and give this one a go. Okay, so in part A, the answer here is x equals 2. And why is the answer x equals 2? Well, remember that when you've got any fraction, you probably learnt this way long ago when you were dealing with fractions, is you can never have the number 0 on the bottom of a fraction, or effectively you can never divide by the number 0. So therefore, I need to think what number of x will make the whole of the denominator equal 0. And the answer there is 2 minus 2 will make the bottom 0, so x can't be the number 2. So x equals 2 is the number that needs to be excluded as an input value for f. So I can't put 2 into this function because the function will break. For part B, I can plug in the number minus 4 though. So when I plug in the number minus 4 into this function, I'm going to get 3 over 2 take away the number minus 4. When you take away a negative number, you add it, so it's 2 plus 4, that's 6. So the answer there is a half. Moving on to part C, express inverse function f inverse in the form f minus 1 at x equals ... So what I need to do here is I need to set up my function, and then equals the output letter we use for y. Now I need to rearrange this to make it x equals something. So the first thing I'm going to do is multiply by the denominator of the left hand side. So that's 3 equals y bracket 2 minus x. Then you expand the brackets, 2y minus xy. I'm making x the subject and it's negative at the moment, so I'd quite like to make it positive just by adding it onto the other side. Then I will take away the 3 onto the other side. And then the final thing I'll do is I'll divide by y, so it's going to be 2y minus 3 over y. And that's virtually my answer, but I'll write out my final answer, f inverse x, as 2x minus 3 over x. There we are, that's the inverse function. Remember, we swap out the y letters for the x letters, and there we are, that's our final answer. We just went through a bit of rearranging algebra here, so first of all we expanded the brackets. Then we moved the xy onto the other side. Then we subtracted 3, then we divided by y, and then we wrote our final answer, replacing the y's for the x's. You could have had an alternatively correct answer here of 2 minus 3 over x. Okay, let's move on to the next question. Pause the video and give this one a go. Okay, so for part A, find f(g) of x, so that means that function that applies g first, then f afterwards. So I need to do the g function first, which is 1 over x minus 2, and then after that I'm going to put this value into the x position in the f function. So it's going to be all of this in the x position, and then you carry on the f function plus 3. So this is the answer to the question. f(g) of x equals 1 over x plus 2 plus 3. Moving on to part B, express the inverse function g inverse in the form g inverse x equals. So what do we do here? We set up 1 over x minus 2 equals the output letter of y, and then we rearrange the formula to get a formula that takes output numbers back to input numbers. The first thing we'll do here is we'll times by x minus 2. So it's going to be 1 equals y bracket x minus 2. Let's expand the bracket next, so it's going to be xy minus 2y. We're making x the subject here, so x equals something. So I'll put the 2y onto the other side. And then I'll divide through by y, so it's 1 plus 2y over y equals x. So therefore, I've now made x the subject. It's at the front of the formula, or at the back of the formula, it doesn't really matter. And we've got all the other things on the other side. So therefore, it's g inverse x. Remember to use the correct letter for the inverse function you found. Equals 1 plus 2x over x. And remember, what you do here is you replace the letter y for the letter x in your final answer. Okay, let's move on to the next question. Pause the video and give this one a go. Okay, so for part A, I'm going to do part A a very sneaky way. What we're effectively saying here is that if we take some value and apply the f function, it goes to another value. But if we take the answer of 50 and we apply the inverse function, it will take us back to the number 3. So all I need to show here is that if I were to start with the number 3 and do the function, I would get 50 as my output answer. So what I'm going to do here in my answer to part A is just put the number 3 into the original function. Not the inverse function, the original function, because 3 is effectively my input number, 50 is effectively my output number, because remember inverse functions take output values back to input values. So let's put 3 in, it's going to be 3 cubed, so that's going to be 27, 2 times 27 is 54, take away 4, that's 50. So there we are. I've shown the answer to part A in a very quick and sneaky way. The functions g and h are given by g of x equals x plus 2 and h of x equals x squared. Find the values of x for which h g of x equals this expression here. So I need to find the values for which h of g equals this thing here. That doesn't mean that h of g of x equals this thing here. We just need to find the values for which it does equal it. So I need to first create the function hg of x. This means do the g function first, which is x plus 2. And then once I've done x plus 2, I then need to put x plus 2 into my input where x is. So it's going to be x plus 2 squared. We can then expand these brackets by pretending that we have 2 of them multiplied together. That's what you do when you square, you have 2 of the same thing multiplying together. So this is going to be x squared plus 4x plus 4. So now comes the part of the question where I need to do x squared plus 4x plus 4 and set it equal to 3x squared plus x minus 1. And I need to solve this equation now. So what I'm going to do is I'm going to move everything onto the right hand side, not leaving anything behind. So 0 is left behind. Take away x squared first, now take away 4x, that's minus 3x. And take away 4, so I'm now down to minus 5. Let's see if we can now solve this by factorising rather than having to use our quadratic formula. I think if I have 2x minus 5 here and plus 1 here, then x can equal 2.5. Or x can equal minus 1. So I've solved it by factorising here. This is what it would be. Factorise this expression here. Remember, the way you factorise is you set up 2 brackets. The front 2 must multiply together to make 2x squared. The back 2 must multiply together to make minus 5. And then when you do some multiplying out on the x terms, you get minus 3x. And I'm going to get minus 5 plus 2, that is minus 3x. And then you need to think what x values will make each of these brackets equal to 0, because that's the only way you can multiply to make a 0. It's by 0 times something, or something times 0, that will give you 0. So 2.5 will be the perfect number to make this bracket 0, and minus 1 will be the perfect x value to make this whole bracket equal 0. So these are the 2 answers for this question. 2.5 and minus 1 are the values for which hg of x equals 3x squared plus x minus 1. Let's move on to the next question. Pause the video and give this question a go. Okay, so let's give this question a go now. So the first thing we need to do is put 8 into the f function. So 8 minus 6 is 2. 2 divided by 2, that's 1. Find the inverse function. So what we do there is we set up x minus 6 over 2 equal to the output letter of y. And then we want to create a function that takes our output letter y back to the input letter. So we rearrange the formula to make x the subject. So we times by 2 and then add on 6. So then we write our final answer here as 2x plus 6. This function will do the reverse operation to x minus 6 divided by 2. The function g is defined by the g of x equals the square root of x minus 4, for which values are not possible input values. Now remember, we're not allowed to square root negative numbers, so we're not allowed to use any number for x that will make all of x minus 4 a negative number. So x minus 4 is not allowed to be negative. So therefore any x value that's less than 4 will not be allowed. We're allowed to square root 0. The square root of 0 is 0, but anything that's less than 4 will mean that I can't square root the answer that's inside this square root. So x has to be x less than 4 is not allowed. So the only values that I can put into the g function is anything bigger or equal to 4. Moving on to part D, express the function gf of x in the form g of f equals ... So in this question here we write out gf of x equals, and then which function we do first? It's the f function because that's closest to x. So that's going to be x minus 6 over 2. That's the f function. And then I'm going to take this and put it into the g function. So it's going to be square root, big square root, x. Now instead of x, I'm going to use x minus 6 over 2. Take away 4. And then the next thing will be to simplify the answer, so it's going to be x minus 6 over 2 minus 8 over 2. I've done that so that I can now subtract the two fractions, one from the other. So it's going to be x minus 6 minus 8, so that will be x minus 14 over 2. And there we are, that's the simplified answer of gf of x. Okay, so let's have a go at the next question. Pause the video and give this one a go. Okay, so for the first question here, let's do it down here. It's going to be gf of 7. So substituting 7 into the f function, I'm going to get 21 on the top. And then it's going to be 4 minus 7 on the bottom, so that would be minus 3. 21 divided by minus 3 is minus 7. And then I need to put minus 7 into the g function, so that's going to give me minus 14 plus 1 divided by 3. Minus 14 plus 3 is equal to minus 13 over 3. And well, that's the final answer. You can't simplify that anymore. Moving on to part B, g inverse functions. So what we do there is we set up the function equal to an output value. We'll call that output value y. And then we need to rearrange the equation to form an equation that sends the output values back to x, the input value. So we'll times by 3 first. Then we will take away 1. And then we will divide by 2. So therefore, g inverse x equals 3x minus 1 over 2. And there we are, that's the answer to that question. And moving on to part C, fg of x, simplify your answer. So in this question here, we need to do the g function first. So it's going to be 2x plus 1 over 3. And then after that, we're going to put this value here into the f function. So it's going to be 3. It's going to be pretty messy. 2x plus 1 over 3 over 4 minus 2x plus 1 over 3. Okay, so that looks pretty horrible. It's a 4-tiered fraction. The first thing I'm going to do to this, to make it all easier, is times top and bottom by 3. Because whenever you've got a fraction, you times top by the bottom, sorry, top and bottom by the same, it doesn't actually change the fraction, it just makes it easier sometimes. So I'm going to times top and bottom by 3, and that will get rid of these divide by 3's inside the fractions. So it's going to be 3 bracket 2x plus 1. That's on the top now. So I've divided the top by 3. And this 3 and this 3 will now have cancelled out. What I'm now going to do is I'm going to times the bottom by 3. So in fact the 4 changes to a 12, but the second part just stays as 2x plus 1 without the divide by 3 in it, because I've times by 3 and the two things will cancel each other out. But 3 will still need to times by the 4. So expanding the brackets, it's going to be 6x plus 3 over 12 minus 2x minus 1. Remember, I need to take away everything that's in that bracket. The final answer here is going to be 6x plus 3 over 11 minus 2x. And there we are, that's the answer to that question there. Okay, let's move on to the next question then. Pause the video and give this one a go. Okay, so the first thing we need to do is we need to put 0.5 into this function here, so f of 0.5 equals, it's going to be 0.5 on the top over 3 times 0.5 is 1.5, but then plus the 1 and we get 2.5. If we now double the top and the bottom of this fraction, we're going to get 1 over 5, so the answer here is 0.2. For part B, it's f of minus 1. Now what this means is do minus 1 into the function first, take that answer and then put it back into the f function again. So it's going to be f of, putting minus 1 into the function, we get minus 1 over 3 times minus 1 is minus 3 plus 1. So that fraction there will equal minus 1 over minus 2. The next thing we need to do is change that to a half, because a minus divided by a minus is a positive. And then, we'll recognise here that f of a half is the same as f of 0.5, so actually I can use the answer to part A for the next part here. When you put up the half as the answer back into the f function on the second time, you get an output of 0.2. And then the final one for this question is to find the inverse function f of x, f inverse of x. So what you do there is you take your function and you set it equal to an output letter. We'll call that output letter y. We'll now rearrange the function so that it's now x equals. So the first thing we need to do is we need to times by 3x plus 1 onto the other side, and that creates a function that's all in one line, which is much better to deal with. The next thing we'll do is we'll expand the brackets. It's better to write it as 3xy than anything else because it's the number first, then the letters in alphabetical order. We're trying to make x the subject here, and we've got x's in 2 positions. So what we need to do here is we need to group them together, as in move them onto one side together. So what I've done from this line to this line is take away 3xy. And now all my x's are together on the same side, I can now do a sneaky factorising step. 1 minus 3y will go in the bracket, and just a single x will appear at the front. You can see what's happened here. From this line to this line, I've turned the function into a function that has 2 x's in it, into a function that just has 1 x in it. So that when I divide by what's in the bracket, it perfectly gives me a function where x is equal to something on the other side, the y letters on the other side, some numbers are on the other side, but more importantly, x is not a letter that's on the other side here. It's just x equals something that has nothing to do with x. So the final answer to this question is going to be f inverse of x equals, I'm going to be replacing y with x here, so it's x over 1 minus 3x. And there we are, that's the answer to this question here. Okay, let's move on to the next one. Pause the video and give this one a go. Okay, so we're going to put 11 into the f function here, so it's going to be 22 over 11 minus 1, that's 10. So the answer here is going to be 2.2. Part B, state which value of x can be excluded as an input value for x. Input value for f. Well, I never want this function to be dividing by 0. So when I look at the bottom, I need to think what value of x will make this bottom 0. And the answer to this question is 1. 1 will be the x value that will make the bottom of this fraction 0, because I'm never allowed to divide by 0. So x equals 1 is not allowed. Okay, and the final question here, find f inverse of x. So once again, we take our function and we set it equal to an output letter y. And the next thing we're going to do is we're going to rearrange this to make x the subject, so we've got a formula to turn the output number into an input number. So the first thing we're going to do is we're going to multiply x minus 1 onto the other side. We then expand the brackets, xy minus y. And we're at a similar point here in the question to the one before, where we've got two x's in this function, where we need to group them together and then do some factorising. Before I do that though, I want to minimise the amount of negatives I have in this question, so I'm actually going to add y onto the other side and then take away 2x onto the other side. Now what I'm going to do is if I had space, I would carry on going downwards at this point, by the way. I'm now going to factorise out x. So it's now y equals x bracket y minus 2. And you can see here from this equation here, I've taken an equation where there are two x's in it into an equation where there's just one x in it by doing factorising. The next thing I'm going to do is I'm going to divide by y minus 2. And there we have it. We have a formula that takes a y number, you do this calculation, and it gives you the x value. That's an output number taking you back to an input number, and that's what inverse functions do. So the answer to this question here is f inverse x equals x over x minus 2. Okay, let's go through the steps here. What I've done is I've times by x minus 1. I have then expanded the brackets. The next thing I've done is I've added y onto the other side, and the reason for doing that is to just make it so that there are fewer negatives in the question, in the answer. The next thing I've done is I've taken away 2x onto the other side. Then I've done the factorising step. Then I have divided by the bracket. And then my final answer is here. An alternatively correct final answer will be minus x over 2 minus x. That will also be correct. You can see the difference between this answer and this answer. You just times the top and bottom by minus 1, and you've got the same thing. Okay, let's move on to the next question. Pause the video and give this one a go. Okay, let's get started on this question then. So express the composite function g f of x in the form gf blah blah blah. So this means we're going to do the f function first. So g f of x equals, so it's the f function first, that's 2x squared plus 1. And then what we do with that is we put 2x squared plus 1 into every single place there is an x in the g function, so 2 positions here. So it's going to be 2 times 2x squared plus 1 over 2x squared plus 1 minus 1. And now let's simplify. It's going to be 4x squared plus 2 over 2x squared, because the plus 1 and the minus 1 cancel out. And then we can also divide by 2 on the top and bottom in all the different positions where there is a 2, because all the numbers are even. So it's going to be 2x squared plus 1 divided by x squared. So therefore, if we want to express it in this form here, it's going to be gf colon x towards 2x squared plus 1 over x squared. And there we are, that's the answer to this question written in the correct form that it asks for in the question. Moving on to the next part, express the inverse function, g inverse from x to something. So we'll start down here actually, we'll do 2 columns, it will go down here and down here. So remember, the way we do this is we set y equal to the g function, 2x over x minus 1, and then we rearrange and make a formula that says x equals something to do with y's. The first thing we do is we move the fraction onto the other side. Okay, so now it's all on one row, that looks a bit better. Let's now expand the brackets. Okay, now we have 2 positions where the x value is. So we need to move them onto the same side. Anything that doesn't have an x needs to move onto a different side, and then we can factorise. So I think what I'll do first is I will move the y onto the other side. The reason I'm doing this is to reduce the amount of negatives that I'm going to have in my final answer. So now that everything's positive, now I can make a decision as to which side I want the x's on. But I think I'd much rather have the x's on the left hand side, because that way I'll only have 1 negative term rather than 2 negative terms, which would be the case if I did it the other way round. The next thing I'll do then is I'll factorise out the x. So what I've done from this step to this step here is I've just factorised the left hand side. LHS stands for left hand side. What that means is I've converted an expression that says xy minus 2x. I noticed that there's an x in common between both of these terms, so I've put that x at the front of a bracket, then inside the bracket goes y minus 2. The next thing I'm going to do, if I had more space I would do it down below, but I'm going to now move up here, is divide by y minus 2. So it's going to be x equals y divided by y minus 2. And that's basically my answer. I've now got a formula that says x equals something to do with y's on the other side. Other numbers appear on the other side as well. No other x's appear on the right hand side. So therefore, the inverse function is going to be x over x minus 2. And I'd write this in the correct form that it's asking for in the question. G inverse colon x sends it to x over x minus 2. So this answer here is the correct answer in the correct form that it was looking for in the question. Okay, let's move on to the next one. Pause the video and give this question a go. Okay, so starting on the first part then, gf of minus 4, so that means put minus 4 into the f function first. So if we put minus 4 on the top, that's going to give us minus 12 over, if I put minus 4 on the bottom, that's going to give me minus 6 in total. Minus 4 take away 2 is minus 6, and then minus 12 divided by minus 6 is just 2. Now I can put the 2 into the g function next, so that's going to be 8 over 5, or in other words 1.6. So the answer to part A is 1.6. Moving on to part B, express the composite function fg of x in the form fg of x equals ... Give your answer as a single fraction in its simplest form. Okay, so this is going to be fg of x. Now given that g is the letter closest to the bracket, that's the one I have to do first. 4x over 5 is the g function. Now the next part is the trickier part, because what I have to do there is I have to put the g function into both positions of x in the f function. So it's going to be 3 times 4x over 5, that's going to be 12x over 5, So that's the top part of this f function divided by 4x over 5 take away 2. Okay, now this is looking pretty difficult. It has asked for it as a single fraction, and at the moment we've got a double, in fact a quadruple tiered fraction, which is not what we're after. The sneaky shortcut from here to the next line is to times everything by 5. Times everything on the top by 5, times everything on the bottom by 5. So effectively timesing by 5 over 5. So let's see what will happen there then. On the top it's going to turn into 12x, because 12x divided by 5 times by 5 on the top will give me just 12x. On the bottom, 4x over 5 times 5, that's just 4x. And then minus 2 times 5, that's minus 10. The next thing we need to do is now half everything on the top and the bottom, because they're all even numbers. So it's going to be 6x over 2x minus 5. And there we are, that's the answer to the combined function f g of x. So the sneaky trick here was to spot that on the top and the bottom of the original function I had a divide by 5. So what I did next is I times top and bottom by 5, because remember, when you times top and the bottom of a fraction by the same value, your fraction stays the same value, it just changes the numbers in the fraction. Okay, so there we are, that's the answer to this question here. Let's move on to the next one, part C. Express the inverse function of f in terms of f inverse of x. Okay, so the way we do inverse functions is we do y equals 3x over x minus 2. And now we rearrange the equation to make x the subject. So first of all, I need to get rid of the fraction component, so I'll times both sides by x minus 2. And I'll multiply it across the other side in a pair of brackets. The next thing I'll do is I'll expand those brackets. Xy minus 2y equals 3x. Now I need to realise that I've got two different places where there is an x letter. So that means I need to group them on the same side. I think what I'll do first though is I'll move the 2y onto the other side so everything's now positive, and now I can make a decision as to what side I want the x on. I think I'll have the x on the left hand side because that will reduce the amount of negatives that are going to be in my final answer. Now that I've got all my x's on the same side, I'm now going to factorise. And now I'll divide by what's inside the bracket. And there we are, that's our final answer. So the answer here is going to be f inverse x equals, and then remember our final answer replaces the y letter for the x letter. So there we are, that's our final answer in this question. So to go through all the steps again, we times both sides by the denominator, then we expanded the brackets. The next thing we did was we added 2y onto both sides so that the negative component was now positive. Now that everything's positive, we can now make a decision as to what side we want the x's on. So then took away 3x to move it onto the left. Then we factorised the left-hand side. Then we divided by what was inside the bracket to move the bracket onto the other side, to leave just x on its own. And there we are, that's the answer to that question. Okay, let's move on to the next one. Pause the video and give this one a go. Okay, so let's get started on this question here. So the first question is find the value of g of 1. That means plug the number 1 into this fraction here. So it's going to be 1 over 2 minus 5. That will make it 1 over minus 3. So that will make it minus 1/3. State which value of x must be excluded from your input of g. Well, it would be any x value that would make the denominator of the fraction 0. So I think if I put x equals 2.5 in here, then it would be 2 times 2.5 is 5. 5 take away 5 is 0. That would mean that I have a 0 on the bottom of a fraction, which you're not allowed to do. You're never allowed to divide by 0. So using 2.5 as the input is not allowed. Okay, moving on to part C. Find GH of x and simplify your answer. So GH of x, this means we do the h function first, the one nearest to the bracket, and that's just x plus 4, nice and easy. The next thing we now do is we put x plus 4 into every position in the g function where there is an x. So it's not going to be x, it's going to be x plus 4 now. So it's going to be x plus 4 over 2 bracket x plus 4 minus 5. So on the top it's going to be x plus 4 over 2x plus 8, expanding the brackets, and simplifying it, it's going to be x plus 4 over 2x plus 3. And there we are, that's the answer to that question. Okay, moving on to part D, express the inverse function g inverse in the form g inverse dot dot dot. So, remember the way we do inverse functions is we set up y equals x over 2x minus 5. And now what I'm looking to do is I'm looking to rearrange the formula to make x the subject. So the first thing I'll do is I'll multiply the fraction, the denominator, onto the other side. So I'll multiply by, in the brackets, 2x minus 5. Then I'll expand the brackets, 2xy minus 5y equals x. You've seen in a few examples now that I'd like to actually move the 5y onto the right hand side to make it positive. So from this step to this step we have expanded, and from this step to this step we've added 5y onto both sides. Now that everything's positive, now I can make a decision as to what side I'd like my x on so that I can then factorise it. I think I'll move the x onto the left hand side, so it's 2xy minus x equals 5y. So from this side to this side I've taken away x. And now I can factorise. Factorising is so important here. You wouldn't be able to get the question correct without factorising. Factorising turns an expression with two x's in it into an expression with just a single x appearing, because now I've spotted there's a common factor of x between the two terms. That will go at the front of a bracket, just a one bracket factorisation. Inside the brackets will go 2y, and then I'll just need a minus 1 on the end here, just for something for the x to multiply by to make x. The last thing I'll do is I'll divide by what's inside the bracket, so it's going to be 5y over 2y minus 1. Okay, so therefore the final answer in this question is going to be g inverse x equals 5x over 2x minus 1. And there we are, that's the answer to that question. Okay, let's move on to the next one. Pause the video and give this question a go. Okay then, so first thing to do is just to put minus 4 into the f function. So that's going to be 3 minus 2 lots of minus 4. Now when it's minus 2 times minus 4, that makes minus 8, so plus 8, so it's now going to be plus 8, so that makes 11. Moving on to part B, express the inverse function of f in the terms of f inverse x equals. So the way we do inverse functions is we set up y equals 3 minus 2x, and then we start rearranging to make x the subject. So I think what I'll do is I'll add 2x onto the other side first, then I will take away y onto the other side, and then I will divide by 2. So therefore the final answer here is going to be f inverse x equals 3 minus x over 2. Inverse functions questions are more like rearrange formula questions, really. Okay, the g function is now x squared minus 5. Solve the equation g f of x equals f of x and show you're working clearly. Okay, so the first thing I'll need to do is I'll need to create both of the functions. So the left hand side, g f of x, will be g lots of the f function, that's 3 minus 2x. Now I'm going to put this into the g function, so it's going to be 3 minus 2x squared minus 5. Let's now expand the brackets on that. Remember, the way that we expand a square bracket is we multiply it by itself. That's what squaring means, multiply it by itself. So it's going to be 9 minus 6x minus another 6x and then plus 4x squared. So the answer is going to be 4x squared minus 12x, and then we'll have a 9, but then take away the 5, so that would be plus 4. Okay, so that's the answer to g f of x. Now let's work out what f of x is. So we put the f function in first, that's going to be 3 minus 2x. And then we put 3 minus 2x back into the f function again. So it's going to be 3 minus 2 lots of the inputs, which is 3 minus 2x. 3 minus 2x. Let's expand the brackets. It's going to be 3, take away 6, plus, for the double negative, 4x. So it's going to be 4x minus 3. Okay, so we've done a lot of the hard work now. We've got the left-hand side expression, that's this thing here. We've now got the right-hand expression, that's this thing here. Now we just need to solve for when the two things are equal to each other. 4x squared minus 12x plus 4 equals 4x minus 3. Now this to me looks like a quadratic equation where I need everything to move onto the left-hand side and then I can solve the quadratic equation. So it's going to be 4x squared, so remember I need to take away 4x from both sides, that's going to be minus 16x, and then I'm going to have to add 3x onto both sides as well, so add 3 onto both sides, because I've got a minus 3 on the right, so it's going to be plus 7 equals 0. So now I'll need to maybe use the quadratic formula. Yes, I probably will have to. So it's going to be, remember the quadratic formula is minus b plus or minus square root of b squared minus 4ac over 2a. This one here is the number a, this number here is the number b, this number here is c. So it's going to be 16 plus or minus the square root of b squared, that's going to be minus 16 squared, minus 4 times 7, all over 2a, that would be 2 times 4. So, bear with me while I grab my calculator to work this all out. Fraction button, 16 plus the square root of 16 squared minus 4 times 7, all over 8. Oh, it does factorise, it doesn't matter. So it's going to be x equals 3.5. And then I need to change the plus symbol just before the square root to a minus symbol to get the other solution. X equals 0.5. So there we are, that's the answer to that question there. Pretty difficult question, that one. Involves a lot of topics, solving quadratic formulas, functions. So yeah, a good typical exam question, that one. Okay, let's move on to the next one. Pause the video and give this question here a go. Okay, so part A is show that GF of 1 equals minus 19. The way I want you to approach this question is to just basically ignore for now that the answer is minus 19. At the end of your answer, you should get minus 19, but I want you to ignore it when you actually do the question. So it's going to be GF of 1. So what that means is we put 1 into the f function first. Whoops, this one here is the f function. Looks like I missed the f. It's going to be 1 minus 5 times 1. That's 1 minus 5, which is minus 4. Now that I've got minus 4 as my answer to 1 being put into the f function, now I'm going to put minus 4 into the g function. So that's going to be 1, so equals 1 plus 5 times minus 4. Minus 5 times 4 is minus 20. Add the 1, you get minus 19. Yes, that is exactly what I was hoping for. The answer was minus 19, which is what I was looking for. I didn't need to use it in the question. I just know that that is my final answer, and it matches up with their final answer as well, so that's good. We probably got that question correct. Moving on to part B now. Prove that f inverse x plus g inverse x equals 0 for all values of x. Now what we could do is we could substitute numbers in and show that it will always come out to be 0, but if I was to take all the time to show that it works for all values of x, I'd be there for an infinite amount of time, so that's not the way to do it. The way to do it is to actually work out what the inverse function for f is, what the inverse function for g is, add the two together, hopefully it will give us 0. So the way we work out an inverse function is we set y equal to the function. So I'll do it for the first one here. Y equals 1 minus 5x. I'm making x the subject, so I'll add 5x onto the left hand side. Take away the y onto the right hand side and then divide through by 5. So I'm going to get 1 over y, so 1 minus y divided by 5. So therefore the inverse function for f is 1 minus y over 5. Now what might be helpful for later is I could actually split this fraction up into 1 over 5 minus y over 5. I'll do the same for the g function, so y equals 1 plus 5x. In this case I'll just take away the 1 straight away because my x term is positive, and then I'll divide through by 5. So it would be y minus 1 over 5 equals x. So therefore the inverse function for the g function is x over, I was supposed to replace the y for an x, wasn't I? There we are, x. X minus 1 over 5. So therefore it might be better written as x over 5 minus 1 over 5. Alright, so now that's all that's left for us to do is now to add these two things together. So it's going to be, therefore, f inverse x plus g inverse x equals 1 over 5 minus x over 5 plus x over 5 minus 1 over 5. And what you can see here is that the 1 over 5s will cancel, 1 positive, 1 negative. The x over 5 will cancel, 1 positive, 1 negative. So I just end up with 0, which is exactly what they were looking for me to show. I've now just proved it using algebra. Okay, let's move on to the next question. Pause the video and give this one a go. Okay, so let's have a go at this question now. So part A, we're putting a half into the f function, so it's going to be 1 over 0.5 squared plus 1. And probably the easiest thing to do here would be to grab your calculator and work it out there. So 1 over 0.5 squared plus 1 equals 4 over 5. Moving on to part B, g is a function such that the g function equals the square root of x minus 1. Find f, g, give your answer as simple as possible. So it's the f, g function we're making here. So that means we need to do the g function first. The g function is the square root of x minus 1. Then we're going to put square root of x minus 1 into the f function. So let's go for it. It's going to be 1 over x, so that's root x minus 1. Then it's squared plus 1. Now hopefully what you remember about squaring and square rooting is that they're opposite functions. Effectively the two things will cancel each other out. So it's actually going to be 1 over x minus 1 plus 1. The square and the square root symbol effectively cancel each other out. So you're just left with what's inside the square root, which was x minus 1. And obviously the minus 1 and the plus 1 will also cancel each other out. So actually your final answer here is 1 over x. So f g of x equals 1 over x. And there we are, that's the answer to this question. Let's move on to the next one. Pause the video and have a go at this question here. Okay, so the answer to part A, we need to consider what x value would make the fraction, bottom of the fraction, equal to 0, because you can't ever divide by 0. You can't ever have a fraction with 0 on the bottom. So that would mean that x could not equal 0, or x equals 0 is the value not allowed to use for the f or the g function. Moving on to part B now, solve gf of something, a in this case, equals 3. So the first thing we should probably do is create this thing on the left hand side and then see if it can equal 3 at any point. So gf of a, so I'll put a into the f function first, so that's going to be 2 over a. And then I'm going to put 2 over a into the g function next. So in this position here, in this position here, wherever there's an x, I need to now put 2 over a there. So that's going to be 2 over a plus 1 over 2 over a. Now, hopefully you've seen this little trick before. I think I've done it twice in this video so far. How do I sort out this fraction now? Well, the easiest thing to do here is going to be to times the top and the bottom of the fraction by a. Now, what's going to happen here? Well, I'm times everything on the top by a and everything on the bottom by a. 2 over a times a, that's just leaving me 2. So the first thing here just turns into 2. Because I've got a divide by a and a multiply by a, and those two things are opposites. So they cancel each other out. Then it's going to be 1 times a, which is just a. And that's going to be over 2 over a, 2 divided by a, times a. Times and divide cancel each other out, so you're left with just 2. So the next thing we now need to do is find for when this thing can equal 3. So we now need to solve 2 plus a over 2 equals 3. So, a little simple equation here, times the 2 onto the other side, you get 6, take away the 2, and you get 4. So 4 is the answer for a. When you put 4 into f and then the answer to that into g, you get an output of 3. Moving on to part C now, find the expression of g inverse x. So the way we do that is we set up y equals, and then the g function next. And then we rearrange this to make x the subject. So it's xy equals x plus 1. Now we need to group all the x's together, so it's xy minus x equals 1. And now we do the factorising step to turn two x's into a single x. Then we divide by what's inside the bracket. And there we are. We've created now a formula where we've got x on one side, everything else on the other side. So therefore the answer to this question is g inverse x equals 1 over x minus 1. And there we are. That's the answer to this question. Okay, let's move on to the next question then. Pause the video and give this one here a go. Okay, so for part A, all we need to do is put 3 into the f function, so 3 times a half, well that's 1.5, plus 3, that makes it 4.5. State which value of x cannot be used for the input value of g. So we need to think what x value will make the denominator of the g function 0, because you can't ever divide by 0, or you can't ever have a fraction that has a 0 on the bottom. I think if we used 1.5, then that would make the denominator 0. So 1.5 is the answer we're not allowed to use for x in the g function. Okay, let's now move on to part C. It looks like a really tricky question, this one. Solve f inverse x equals gf of x. So I think the first thing we need to do is create the functions for both the left and the right hand side, then put them equal to each other and see if there's an answer for x. So the way we do inverse functions first is we do y equals, then the function, in this case it's the f function. So in this case we'll take away 3 from both sides, and then double both sides to get rid of the half. So the answer to the f inverse function here is 2x minus 6. Let's now create the gf of x function. So gf of x. In this case we do the f function first because it's nearest to the brackets. So that's going to be a half x plus 3. The next thing we do is we put half x plus 3 into every x input value, input position in the g function. So in this case it's going to be 14 over 2 times a half x plus 3 minus 3. So simplifying this, it's going to be 14 over, expanding the brackets, I'm going to get x plus 6 minus 3. So this is going to give me 14 over x plus 3. Okay, so there we are. That's the simplified gf of x function. Now we've just got to now solve these two things when they're equal to each other. So 2x minus 6 equals 14 over x plus 3. Now this looks like a very difficult equation to solve, but no matter what the equation is, whenever we see something that looks like this, where we've got a fraction on one side, it's always the best thing to do to times that fraction onto the other side, or generally it's the best thing to do to times that fraction onto the other side. So times in the denominator onto the other side, you get 2x minus 6, x plus 3 equals 14. Now I've put both of the terms in brackets because I want everything from this left hand side to multiply by everything that I'm timesing by onto the left hand side. The next thing I'll do is I'll have to expand the bracket, so 2x squared minus 6x plus 6x minus 18 equals 14. So I'm seeing here that the 6x's will cancel each other out. That's pretty helpful. The next thing I think I'll do is I'll add the 18 onto the other side. So 14 plus 18 gives me 32. Then I'll half both sides to get 16. So now I've got x squared equals 16. So therefore the answer could be 4 or minus 4. Because when you square minus 4, you get 16 as well. So you get two answers here, 4 and minus 4. So there we are. That was a really difficult question. That one. It was a single question that involved an inverse function, a composite function, and a solve component. So that's probably as hard as these functions questions will get. Let's move on to the next one. Pause the video and give this question a whirl. Okay, so getting started on part A, it's another inverse functions question, so we all should definitely know what to do by now. We should definitely know that you set y equal to the function and then start rearranging. So it's y bracket x minus 3 equals 4. The first thing you do is you times by the denominator of the any of the denominators, in this case the right hand side. Then you expand the brackets. You could divide by y here, I prefer to expand the brackets. Then we're making x the subject, so we'll add the 3y onto the other side, 4 plus 3y, and then we'll divide by y, so it's 4 plus 3y over y. So we've divided by y from this step to this step, we've added 3y from this step to this step, and we have expanded the brackets from this step to this step. The final answer is going to be f inverse x equals 4 plus 3x over x. So there we are, that's the answer to that question. Let's now have a go at part B. Solve fg of a equals 1, show your algebraic work clearly. So we'll have to create the fg of a function first before we get started, so that means we put a into the positions of x in the g function first. It's always the function closest to the brackets. So it's going to be a minus 2 over a. Now the next thing we need to do is we need to put this value into the input positions x in the f function now. So it's going to be 4 over a minus 2 over a take away 3. Now the way that we can sort out this divide by a here is if we times the top and the bottom by a. So what will this turn into? Top will be 4 times a, which is 4a, over, now think about it, it's going to be this first bit here times by a, so that's going to be a minus 2 divided by a times by a. Now you've got to divide by a here, times by a here, and the two things are opposites, so they'll cancel each other out. So I'm just left with what's on the denominator, so what's on the numerator of this term here. I expand the brackets of this component here as well, and it will be minus 3a. Let's now simplify what I've got on the bottom. So it's going to be a minus 2 minus 3a, so that'll make it minus 2a minus 2. So that's the fg of a function, and now I need to set this thing equal to 1. So it's going to be 4a over minus 2a minus 2 equals 1. So the first thing I'll do is I will times the denominator onto the other side. Add the 2a onto the other side, so I've now got 6a on the left hand side, and then divide by 6, so I've now got minus 2 over 6. I could simplify this fraction to minus 1/3. So there we are, that's the answer to the question there. Minus 1/3 is the answer there. Okay, let's move on to the next question. Pause the video and give this one a go. Okay, so starting with part A, state both values of x which cannot be used as input values into f. Well, that would be any x value that would mean the denominator of the fraction equals 0, or that means that you can't divide by 0, or you can't have a fraction that has a 0 on the bottom. So x equals minus 1 would make the first fraction 0 on the bottom, and x equals 2 would make the second fraction have a 0 on the bottom. So those two values are not allowed in this question. Next question is to put 0 into the f function, so that's going to be equal to 3 over 0 plus 1, that's 1, plus 1 over 0 minus 2, that's minus 2. And the best thing to do now would be to just plug this into your calculator. It's going to be 3 take away a half, which is 2.5. Moving on to the next question, part C. Find the value for which f of x equals 0. Show your algebraic work clearly. So this is a question that relates to algebraic fractions. We want to set our function equal to 0. Okay, so the best thing to do here would be to now add these functions, these fractions together here. Now, the way that you add fractions together is to make sure that the denominators are the same. So if I already have an x plus 1 on the bottom of the first fraction, but I also need to make sure they have common denominators, I must also make sure that it has an x minus 2 on the bottom. If I put an x minus 2 on the bottom, to balance it out, I'll put an x minus 2 on the top, so I've still got effectively the same fraction here. I'll do exactly the same for the second term. I've already got x minus 2 on the bottom of on the second fraction, but I need to have common denominators with the first one, so that must also have an x plus 1 on the bottom. And if it has an x plus 1 on the bottom, I need to put an x plus 1 on the top, so that the fraction stays equivalent to the line above. Now, if this fraction here adds together to make 0, it must be the case that it's just the numerator that will add together to make 0. It doesn't matter what you have on the bottom of a fraction. If you have a fraction where 0 is on the top, then your fraction is equal to 0. So it's going to be 3x minus 6 plus x plus 1 equals 0. That means 4x equals, we'll add 7 onto that, so add 6 onto that side, take away 1, so that would be 5. So therefore x equals 5 over 4. So So there we are, that was the answer to that tricky question there. Don't worry if you didn't quite get that. Maybe wait until you've done the algebraic fractions video for you to really have a good go and understanding of that question. But it's a question that links functions to algebraic fractions, which is definitely possible. Okay, let's move on to the next question. The questions appear on the top right hand side of your screen over here, and we may need to use this graph to work out the answer to this question. Pause the video and give this one a go. Okay, so for the first question here, what I'm just going to identify first is that the x-axis is the axis we use for our input values. So you can think of this as like the input axis, and the y-axis, think of that as the output axis. So if I'm doing f of 0, 0 is my input value, so along this horizontal line I'm going to go to 0, and I'm going to spot that my output here is going to be 5. So I go find my input value going from left to right, and then go either up or down to find out what the output is. And the output here is in between 0 to 10, which is 5. So the answer to part A is 5. Now the answer to part B is slightly more complicated. For which values of k does the equation f of x equal k have only one solution? Now let me just show you an example that's not correct. If I was to use the number 10, then the number 10 as the output value. So if I'm doing f of x equals k, the k letter here is representing the output. So if I use, for example, 10 as the output value, then actually I'm going to get lots of different values for x that could have given me 10 as my output value. I'm looking for what values of k will only give me one answer. So let's rub 10 out because that was incorrect. In fact, if you look at where the graph finishes at a maximum point and where the graph finishes at a minimum point, that will give you some clue. Anything in between this region from here to here will actually give you 3 solutions. Anything on the lines will give you 2 solutions, one at the peak, one at the trough, and then the other one from left to right. So actually the answer is anything from the line upwards or from this line downwards. So therefore k either has to be bigger than, 13? K has to be bigger than 13, or k has to be less than 5. So there we are. Those are the values for k that you are allowed to select if you only want one solution to f of x equals k. Pretty difficult question, that one. I won't worry too much if you don't quite get it. It's like a bonus question, really. Let's move on to one more where there's a little graph involved. Remember, x is the input axis, y is the output axis. Pause the video and give this question a go. Okay, so for parts A and B, you actually don't need the graph. The graph only comes in at part C. So if you didn't understand that, then maybe have another go. The f function is just referring to the stuff up here. So the f function is the root of x minus 6. Find f of 10. So it's going to be 10 minus 6 is 4. The square root of 4 is 2. So the output here is 2. State for which value of x must be included. Which values of x must be included for possible input values of f? Well, you're not allowed to ever square root a negative number. So here, if x was anything less than 6, then that would not be allowed because you'd be square rooting a negative number. Okay, let's have a go at this question now. It's part C, which is g of 2. So you would go to 2 on your x-axis, up and across, and that would give me the answer of 7. So 7 here is the output. You would go along to 2 on your input axis, up to the graph, across to your output value, and you would see here the answer is 7 over here. Moving on to part D, g of 0. So you would go to 0 on your input axis, up you would go to 15. So this is 15, so it'd be f of 15. So g of 0 gives you 15, but now we have to put 15, the answer, into the f function. So it's going to be the square root of 15 minus 6. 15 minus 6 we all know is 9, square root of 9 is 3. So the answer to part D is 3. And let's move on to the final question in this big long functions video. It's a hard one, so hopefully you're prepared. Pause the video and give this one a go. Okay, so before I do go through the answer to this question, I really do hope you've given it a really good try. Don't just give up after a couple of minutes. This question is a bit of a brain teaser, so what I'd like you to do again is pause the video again and have a really, really good try at it. Alright then, let's now have a go at this question. So, let's use the first bit of information here. We know that g, when you put 3 into it, gives you 20. So what we could say therefore is that g3 equals a times by 3, that's 3a, plus b will equal 20. Okay, so this bit here is effectively information number 1. We're going to be forming simultaneous equations here, so that's effectively simultaneous equation number 1. Now we're going to do this thing here, and have a look at what this means. I think what the best thing to do here will be to make the inverse function for f first. So let's do y equals 5x plus 3. Let's then do, let's now take away the 3 onto the other side, and divide by 5. So the inverse function for x, so the inverse function for f is x minus 3 over 5. So therefore the inverse function with 33 put into it is going to be 33 minus 3 over 5 equals 6. So this is going to be that when I put 1 into the g function, I get 6 as my output. So g of 1 equals, that would be a plus b, which equals 6. Now this here is my second of my 2 simultaneous equations. So we'll call that maybe double star. No, in fact we'll call it simultaneous equation number 1 and simultaneous equation number 2. So let's write them out again. Simultaneous equation number 1 is 3a plus b equals 20. And simultaneous equation number 2 is a plus b equals 6. And I think what I can do is if I do equation 1, take away equation 2, then that will cancel out the b's. So it's going to be 2a equals 20, take away 6 is 14. So therefore a is equal to 7. And therefore plugging it back into equation number 2, 7 plus b equals 6. Therefore b is equal to minus 1. And there we are, that's the answer to the hardest question in this functions video. A is 7, b is minus 1. Right, so hopefully you found that video useful. Don't think it finishes there, so we've got lots more videos for you to have a look at on the revision video channel, the YouTube channel. And make sure you come back and revisit this video every now and then as well, just to refresh yourself with the functions chapter. Make sure you keep those skills topped up, and hopefully you found this video helpful. Thanks very much for watching.